Hi, this is Eric with Math from the Gut. In this final video, I will get a bit personal and try to explain why I always test drive new equations and do math as much as possible directly from the gut. I've preached quite a bit to a number of students over the years, and as they can attest, I'm just sharing a tiny bit of that here. Hopefully, you've listened to my 6 test drives and can already see some of the benefits for yourself. Very few teachers ever really taught me to think like this. Some, maybe just a bit. The idea was generally, do as I do and think as I think. Well, that's great if you're a robot. And robots can blindly follow instructions and do mechanical things much more quickly and accurately than we can anyway. So I would leave that to the robots. But doing things from the gut takes quite a bit of time and effort. So why bother? You might be wondering, what's in it for me? First of all, it can be much more interesting. For me, the classroom and the book were always just a starting point. I would often be the last person in the class to solve a problem after a new idea was introduced, because I hadn't yet played around with it and accepted what was just taught. I just didn't feel ready. The most interesting part usually came later, when I was in the driver's seat, forging my own path and discovering things for myself. I would lie down somewhere, shut my eyes, let my mouth dangle open a bit, and try to make sense of things for myself. And sometimes this would take quite a long time. As much as possible, I wanted to understand things on my own terms and to see what really makes them tick. I wanted to feel as direct a connection as possible to what I was doing while I solved problems. You'll see this idea in a big way in my future videos. Even when other students felt like each lesson was some bitter medicine they had to get down, I would try to find ways to make it more interesting for myself. For starters, I would never just accept that what I was told was true, even if it had been in textbooks for hundreds of years. Simply doing this, simply questioning things, turns what seems like rigid rules into more of a lively debate, even if this debate was mostly just going on in my head. And who knows, for thousands of years, fancy, official-looking books once incorrectly proclaimed that our Earth was the center of everything until people started to question it. But even when I could see that an idea was true, I would always want to understand it more clearly and in many ways as possible. And again, I would always seek ways that are more direct, even if they're a bit less precise. And the fact is that my students already have this skill of questioning things. Big time! I point out how they take a questioning, never say die attitude towards so many things that their parents and others tell them. They do this with amazing insight, energy, and intelligence, without ever having been taught. These students don't blindly accept something that doesn't make sense and sit by quietly. Sometimes they don't even accept things when they do seem to make sense. I always suggest that they take that same feisty attitude into school with them as well. In math, simply memorizing equations and repeating examples until you can do them yourself is just the tip of the iceberg, even if you're getting A's. I know this is horrible to say, but newsflash! Your teacher is just a human being like you, and may have only ever memorized equations himself. He may not know anything different. If you just treat math as a series of recipes that you mechanically apply, you're not learning anything close to what you could be. Throughout life, you can make things much more interesting, even things you really don't care for too much, by actively involving yourself in them. If you have to do something, really have to, you might as well work at finding some meaning in it. For example, I didn't like poetry too much in school, and still haven't quite come to terms with it. But by accepting that I had to do it, developing some curiosity for it, and working hard to understand things in my own way, it turned out not to be too bad, and was even a bit interesting at times. A very tiny spark got lit. Now, as I'm older and have grown curious about more things, I've run into some pretty beautiful passages. And I've even been thinking about opening up those old Cliff Notes and plunging back in. Well, we'll see. I do feel that if I hadn't had that experience with poetry and other things while growing up and made the effort to get what I could out of them, my life would have been shallower. Next, in school, having a strong sniffer for what makes sense can really come in handy. First, it will stop you from making a lot of silly mistakes. By doing math from the gut, you'll start to develop a good sniffer for things, something you'll find that many other students almost completely lack. You'll see other students make mistakes and wonder how they can ignore so many things that go against simple common sense. You'll often sense these mistakes without even having to go through all the details. On the flip side, you'll be much less likely to think you understand something when you really don't. Doing math from the gut is also very helpful when taking multiple choice tests, like the SATs. Even if you don't know how to get the answer, you can often use your sniffer to eliminate some of the choices and improve your odds. Remember all of those evil, incorrect formulas that we tried out? It's sad, but I have no doubt that many students, even those getting A's in honors classes, would just accept and memorize many of those formulas without a second thought. But with a strong feeling in the gut about how things work, you can very quickly see that these formulas are wrong, even if you had never seen the correct Pythagorean theorem before. I know, the 6 test tries that I just did amount to over 1 hour of video time. But the fact is that I would probably notice in less than 1 second if an equation would have failed any of those test drives. This isn't science fiction, folks. Every day, you quickly do much more complicated things already. For example, you can sense somebody's mood with a quick glance. Here, let's try with these faces. And one more time. Believe it or not, much of math can be this quick and natural, but it does take some work. If you had to explain why a certain face looks sad to somebody from outer space, it would probably take a long time and you'd probably try to come up with some rules. For the same reason, I slowed things down to share these new math ideas with you. But when I look at a formula for myself, I don't have a checklist of test drives and then think slowly about each one. It's really not the step-by-step process that I presented. After doing this for so long, I've developed a gut instinct about these things. My sniffer can often detect that something is wrong without even quite knowing exactly what it is until I dig more deeply. This approach of learning math from the gut helped me countless times during my 27 years as an electrical engineer where I worked on cell sites. Now, cell sites are special equipment that hovers over highways, hangs from buildings, and communicates with all of your mobile devices, like iPhones and iPads. A mistake in one of these could cost my company millions of dollars. Since I'm getting personal here, I'll give an example of this without going into all of the details. At work, I had always been a bit queasy about how our cell sites processed a certain signal that was transmitted to us by the mobile devices. Yes, there was all kinds of fancy math to justify what we were doing. Yes, it had been inspected by a lot of very smart people, but it just didn't sit well with me. It seemed like it might not work well when the mobile device was traveling quickly, which would cause this certain signal to appear quite a bit different to our cell site. Then, one day I overheard a comment and learned that for certain reasons, the mobile speed as seen by the cell site would actually be twice its real speed. Now I was really worried. I ran a simulation to test things out on the computer and saw huge problems. I then had to convert my math from the gut feeling into a logical, textbook-like, step-by-step explanation to convince others that we were in real trouble here. Next, I let my creative juices flow and proposed a solution that offered a compromise. A compromise between working at low speeds and high speeds. With help from a colleague to solve my 11 equations, we were able to fix a serious problem perhaps 1 year earlier than would otherwise have been the case. Note that this happened because my sniffer alarm went off, and I spent the time to fully examine things that were supposedly working just fine instead of quickly passing over them. Also, there wouldn't have been any creative juices to flow around if I had always limited myself to just do as I do and think as I think. I always tell folks that it's a win-win situation. If I'm right about a concern, I save people, including myself, a lot of extra work and embarrassment. But if I'm wrong, and it certainly happens, then I'm likely to learn something very interesting along the way. Although most of math is presented as a dry, step-by-step process, most discoveries were not made that way. Seeing something totally new and interesting usually requires a spark, an inspiration. It often happens in a dream. But these sparks only come to the prepared mind, somebody who already possesses a deep understanding of things. If you go through school like a robot and don't appreciate the true power of everything you've seen, it will be much harder to do something original later. Note that the great discoveries only change into those dry, step-by-step formal processes later on when they are shared with the rest of the world. Now, our school system may let you feel like a rock star, and you can actually impress your parents quite a bit by working hard, memorizing step-by-step processes, and getting good grades. I've seen many people even get through college that way. But then I can often quickly see through their mistakes without even having to look at the details. And then, when they are lightly prodded, I can see that they often don't really understand how everything ties together. Not thinking things through thoroughly for yourself also makes it harder and harder to learn new things, since advanced math, much more than other subjects, builds almost entirely on basic math. For example, if you haven't mastered basic math, you're really not ready to understand calculus, even if your school is eager to push you through it and find some kind of way to give you an A through extra credit, take-home tests, curves, redos, etc. Almost anybody can be taught how to do calculus mechanically. If you've memorized enough things, you can do it too. But really feeling the beauty behind it and unleashing its true potential takes more work. Doing this is much more rewarding both now and when you use it in the future. If learned thoughtfully, the ideas in calculus and many other areas of math will be part of you forever. Also, after thinking about a certain formula for a long time, you'll find that it is more difficult to forget when you run into it much later. In fact, you may not even feel like you had to memorize it at all. When you see the proof of the Pythagorean Theorem that I'll provide in a future video, you'll hopefully see that remembering formulas is much easier when you have learned simple, interesting, and direct ways of proving and thinking about them. Sometimes when I can't remember an equation, I find that I can get it back pretty quickly by recalling the story behind it, even many years later. The funny thing is that I have trouble remembering lots of things, like the color of our house, especially since it's one of those annoying in-between colors that doesn't have a basic name. So as my wife can tell you, my memory really is not that good, but it doesn't have to be to remember a lot of things in math. Nice, simple, interesting stories are always easy to remember. Now along this line, I remember a particular final exam that I took in college at Princeton. During that semester, I spent hours lying on my bed until I could make a nice, simple story out of everything in that class. When I entered that exam, I honestly didn't have anything memorized. I simply understood things well enough that I could create the math as needed to solve the problems quite quickly. By the end, everything seemed pretty simple and natural, but I do remember a sudden cold chill running down my spine when I saw students clutching many pages of tiny, hand-copied equations that they were frantically trying to memorize. I was thinking, oh shoot, or something along those lines. Did I really learn that much? Am I missing something? The fact was that I had really learned quite a bit more and was much better prepared than many others to take the next class. I'd gotten to a point where everything seemed like common sense. And that next class used a book that had so many mistakes in it that it really drove the formula memorizers crazy. The teacher would always be giving us long handouts that would try to correct the mistakes in his book. And then these handouts were usually wrong as well. But all of this didn't bother me too much, since his typos were obvious to me and I knew what he was trying to do. And as a bonus, I didn't need to re-memorize all of the equations from the earlier classes when I started this new class the next year. So the bottom line here is that I hope you don't just watch my math videos and learn the specific things that I'll have time to cover. Although that by itself would be cool. But my grand hope is that these videos inspire you to actively think about math in your own way. Perhaps differently than I think about it. If you do, please leave a comment and let me know about it. If you start thinking like this, when you start asking tough questions and looking at things from different angles, then perhaps you'll be more prepared to do something wonderful when a certain ordinary-looking everyday thing crosses your path. Perhaps like the apple that folks say struck Sir Isaac Newton's head when he was away from school during the Great Plague, and made him suddenly realize that gravity also explained things way up in the skies. Now I know that I went on quite a while here, but I had a number of points to make, and I feel strongly about what I'm doing. And I'm hoping that some of this finds its mark with you. I'm also hoping that you can now quickly run through the 6 test drives for the Pythagorean Theorem in your head. You definitely should give it a try. It should take much, much less than the 1 hour I spent presenting them. At most, several seconds for each one after running through this a few times. Any ideas you can share will help me improve what I'm doing and motivate me to continue. And again, if I use your idea, you'll find your name here as part of my mathematical dream team, perhaps right along with William Shakespeare and Robert Frost. See you in my next video.